Let us consider a problem based on conditional probability. A pair of dice is thrown. Find the probability of getting a doublet. If it's known that sum of numbers of the two dice is 10. So let me consider two dice here, die 1, die 2. So you know very well, on each side you will have 1, 2, 3, 4, 5, 6. Similarly, 1, 2, 3, 4, 5, 6. Now, what about the overall sample space elements? That is, you have die 1, die 2. So, you can have 1, 2, 3, 4, 5, 6. So similarly, you have 1, 2, 3, 4, 5, 6. So this is die 1 and die 2. Okay, right. Now, what about the first one? It can be 1, 1. Second one, it can be 2, 1. Third one can be 3, 1. So, likewise it goes. Okay. And similarly, the next row will be, that is 2, this is 2, 2. So, 2, 2. I'm sorry, that is 2, 1, 2. Okay, likewise it goes. So totally you will have, and diagonally you will have 1, 1, 2, 2, and then 3, 3, and then 4, 4, and then 5, 5, and finally 6, 6. So this will be the diagonal elements. So likewise you will get 6 into 6, that is 36 elements, and that is the number of sample space elements in case of two dice throw. Right. And what is given here? A pair of dice is thrown. Okay, we have arrived at the sample space elements, and find the probability of getting a doublet. So that is the getting a doublet is E. Are you able to follow? And then if it is known that the sum of number of two dice, so that is the second event. Sum of number of two dice is 10. So this is F. Got it? Now we have to identify the elements. Is it not? Now the E, let us consider E. Find the probability of getting 2, that is doublets. So let us arrive at the set, that is 1, 1. That is the diagonal one or doublet. That is the same numbers should be repeated. 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So how many we are able to get? 6, is it not? Right. So the number of E is equal to 6. And what about F? F is, that is the sum of dice is 10. So you can have 1 plus 2, no chance. 2 plus 3, no chance. So you can go ahead and you can have 4 comma 6, that is 10. Another chance, 5 comma 5 plus, that is 10. And then 6 comma 4. So this is the only chance. So it means the number of f is equal to how much? 3. And you know how to calculate the probability. The probability of E is equal to what? 6 by 36. Is it not? The probability of F is equal to 3 by 36. Is it not? So, probability of E is equal to, E alone is equal to 6 by 36. And the probability of F is equal to 3 by 36. Right? Now, we need to find out the intersection, that is common to both. So, probability of E intersection F. Okay? So, you just check it up. Where is it possible? 5 plus 5 can be 10. So, identify this one. Okay? So, this is the only chance. 5 comma 5 and also belongs to this 5 comma 5. So, it means we can have only one. Is it not? That is, first we will put the E and F is equal to 1. So, 1 out of 36 will be E intersection F. Are you able to follow? So, probability of E intersection F is equal to how much? That is 1 by 36. So, are you able to follow this? Right. Now, we have to find out the probability, that is the conditional probability. So, apply the formula. Let us apply the formula of conditional probability. So, P of E such that F has already occurred is equal to, what is the formula? P of E intersection F divided by P of F. Okay. Now let us apply P of E such that F has already occurred. Now what is P of E intersection F? 1 by 36. What about the P of F? Where is P of F? P of F is 3 by 36. 3 by 36. So the answer is 1 by 3. Okay. Do you understand?